Okay, question C, here we go. Two circles are inside a square. ABC of side length 1. No surprises. Of course, they chose 1 as the side length. One of the circles is tangent to the sides AB and to BC. Well, as shown in the diagram. The other circle, blah, blah. The circles are tangent to each other. That's very important. Yeah, so that proves that the circles are maximized. Or you know, what's the word? Maximal. Yeah, it sort of fits the whole square. And the area of the larger circle is 10 times the area of the smaller circle. The diagram is not to scale. Well, seldom is it to scale. The sum of the radii of the circles is how many? Okay, so I want radius here and I have a radius here. Yeah, and I want to find the sum. Okay, well, it's obvious that it's less than 1, right? Because the side length of the square is 1, so the sum must be less than 1. Yeah, so E is nonsense. Agreed? Okay, so if I somehow find this extra bit, yeah, because you can move this radii down here, and you know, this is the same, right? Now, I'm not suggesting that this side is exactly the radii, if you see what I mean. Yeah, I'm not suggesting that. I'm just suggesting that if you move it down here, then the whole of this is going to add up to 1. Yeah, I'm not suggesting that the exact length. Okay, I need to be more clear about myself. I'm not suggesting that the green length is exactly the black length. Okay, I'm just suggesting that if you move it down, if you move the radii down and then you add a horizontal distance, it gives you the full side length of 1. Okay, so let's imagine this. How can I find this question mark then? Yeah, once I get the question mark, then I could equate it to 1. Yeah, okay, so we could think about this connecting line. How come? Well, you'll see why. Yeah, let's call this A. I don't know. Yeah, and let's call this B. So A is the bigger one and B is the smaller one. Yeah, the radii of the two circles. Okay, so this connecting black line must be A plus B. No doubt, right? Because they're tangent to each other. The circles are tangent to each other, so the distance between the centers is just the sum of the length of the radii. Okay, now the clever thing here is that if I draw a right angle triangle here, we know that this is 45 degrees. We know that. How come? Because the centers of the circle must lie on the diagonal of the square, right? By the geometry, right? Because they are maximal, yeah, they are tangent to each other. So there's no doubt that that's true. Okay, so which means that that angle there must be 45. And therefore, life becomes easy because you know that the question mark equals A plus B cos 45. Yeah, I'm going to skip the reasoning behind this, you know, easy trigonometry because, you know, you won't be doing the MAT if you don't know this. So that's A plus B times cos 45. So what happens here? Then A plus this question mark plus this B is going to equal to what? It's going to equal to 1, right? That fulfills the whole square. Yeah. So, and then you just solve this. Yeah. So A plus B factorize 1 plus cos 45. And of course, cos 45 is root 2 over 2. Okay, so from now on, you just have to solve for A plus B. Yeah, and the nice thing is that you don't need to exactly know what A and B are. Yeah, I mean, this is such a classic MAT question, right? MAT question always does that. You don't have to find the exact values, but you can find their sum, or maybe their product sometimes, or their difference. They're just clever ways of doing these things. Okay, so again, GCSE rationalization here, which at this point I can't quite do. I mean, how do people do this? Maybe multiply top and bottom by 2 first, and then maybe multiply by, I don't know, 2 minus root 2. Is that what people do? And then over 2, and then that cancels. So of course we have B as the answer. All right, so there you go. And hopefully the explanation of what I was doing here was clear. Yeah, but the green length and the black length, yeah, you can move the B down there such that the whole line is of a side length 1.